Hi, welcome back. Certainly
We
glad you could
begin this
join us
problem
today.
with two pairs of supplementary angles that are not adjacent. We also begin with this given information, and we're going to prove that angle 2 is equal to angle 3. So first we begin with this idea of supplementary angles. So if angle 1 and angle 2 are supplementary, then by definition of supplementary angles, they add up to 180. The same is true for 3 and 4. If they are supplementary, by definition, angles that are supplements of each other add up to 180 degrees. So the reason for those two statements is the definition of supplementary angles. And if you're not sure about that, go back a few videos and we talked about supplementary angles.
That's all there is to it.
Now, why do we know that angle 1 is equal to angle 4? Because that was given.
That's all there is to it.
And we're going to use that information with these two equations. What we're going to do is we're going to replace this angle 1 with this angle 4. We're allowed to make that switch because of the substitution property. If we then subtract this angle 4 to this side, it looks like the angle 2 would be left alone. The 180 is already on this side. And then this positive 4 moving to the other side becomes a minus 4. So we subtracted the the angle 4 to the other side. And we do the same thing for the second equation. So we subtract the angle 4 to this side to leave the angle 3 by itself. And that all was done because of the subtraction property. Now what's great at this point is that they're equal to each other. So we could substitute. So for example, instead of putting 180 degrees minus angle 4, I could put angle 3, and that's what we did right here at the end. And we know we're done with this proof because we arrived to what we were trying to prove. We've discussed before the idea of the bisector. So in other cases we had a midpoint was a bisector, lines could be bisectors, and rays in particular are bisectors, especially when it comes to angles. So an angle bisector is a ray or a line that divides an angle into two congruent adjacent angles. And this proves very beneficial in proofs and also in algebra. So let's begin problem 4 by giving you the information that you need. In this case, we're going to give you the fact that ray RG bisects angle CGF. And if it does that, then it means it forms two equal angles, CGR and FGR. If we replace them with their appropriate expressions, we get this equation. If we subtract from both sides, we get this equation. And we get that x equals 5. However, that is not the value of the angles. So let's find the values of the angles. For example, we know that angle CGR is 4x plus 55. We now know that x equals 5. So angle CGR is 75 degrees. Now there's two ways to proceed with the next angle. We can use the algebraic expression that was given to us. We plug in the x that we got before, and we get the same answer. Or we could have just simply taken the answer we got for CGR and noting that because ray
We don't make mistakes. We have happy accidents.
GR, and make sure to fix that in your notes, we know that ray GR is a bisector, and so if it's a bisector, it creates two congruent angles. So we didn't have to do the additional algebra for FGR, because if CGR is 75, then FGR is also 75.
That's all there is to it.
Problem 5's proof I'm going to do a very unique way, and you could do this proof in different ways as well. And I would challenge you to consider that. So this is what we've been given, and this is what we're proving. And if we study out this diagram, you're going to see that these are vertical angles and these are vertical angles. And I hope you know that vertical angles are congruent. But not all vertical angles are congruent to each other. So in this diagram, it's safe to say that 4 and 5 are vertical angles that are congruent to each other. And then it's safe to say that 6 and 7 are vertical angles that are congruent to each other. However, we do not know if they are all equal to each other. We cannot make that claim. So let's make the claim that angle 4 is equal to angle 5 because of vertical angles. Next, I'm going to write my given statement. Next, I'm going to write my statement about angle 6 and angle 7 being vertical angles. But do you notice what's going on here? If angle 4 is angle 5, but angle 5 is angle 6, but angle 6 equals angle 7, notice a pattern. What I end with here is what I begin with here. What I end with here is what I begin with here. There's a very serious pattern here. Fact 1 is fact 2. Fact 2 is fact 3. Fact 3 is fact 4. Therefore, fact 1 is fact 4 in this case. In this proof, it's because of the transitive property. Now, you could do this a different way with substitution or doing other things, but in the way I did this proof, I wanted to demonstrate how transitive property works.
Hi, welcome back. Certainly glad you could join us
For
today.
your summary, I have 2 what-if questions. For problem 3, how would that problem have been different if the angles were complementary instead of supplementary? And for problem 4, with the bisector, how would problem 4 have been different if we didn't know that ray GR was a bisector? Take some time to think
I
about
want to
that.
thank you from the bottom of my heart.